Hi, I'm George Kondiles, Chief Architect and a co-founder here at Ocient. Today, I'll be speaking a little bit about scale and Ocient's approach to managing the problems associated with it. As any distributed system, Ocient must deal with all sorts of issues that arise in scale. Things like data locality, hotspots, hardware maximization, as well as the normal cases of things like faults and failure scenarios. This is obviously a large and complicated topic, more than I could cover in a short video like this one. So I'll be discussing just a couple of the overall internal approaches that we've taken when designing our system for scale. The first is something that we refer to as cluster of clusters. Generally, in order to account for more load, more storage, more computational capacity, we're required to add more nodes to a system. If I have a system with some number of nodes present on it, and I wanted to add more to it, naively, it might look something like adding them into one giant cloud of nodes available for execution. However, this overall naive approach has the fundamental problem of, unless steps are taken to address it, the total amount of communication required scales as the number of nodes squared. It's a quadratic. This is not ideal, has issues for scale, and also gets away from some of the core design tenets and principles associated with good distributed systems practices of minimizing global information. We prefer not to have everything know about everything, prefer not to have everything have to talk to everybody. To address this is our cluster of clusters concept, where internally we subdivide systems into some number of disjoint clusters. And the number of nodes per cluster and exactly what each cluster do can vary based on what the node's being asked to do. We have different types of clusters within the system. And they can even overlap at times, even though I've drawn them like this. Despite this, the basic idea here then is that each one of these clusters maintains its own local state, often with a consensus protocol mediated only with the peers in the system, not across the entire system. But by maintaining information locally and keeping it locally, the rest of the system is not required to be aware of how the other elements in it are executing. The only decision-making that is necessary is kept local to a small subset of nodes, often stored in placed in the same rack and attached to the same switch in the actual physical data center. The second approach is one that we refer to a level-based query topology. Here I have depicted a basic query plan without any particular operations being displayed. The general idea is that at the leaves of the plan, I/O occurs, and we read records off of disk. They flow up and over the edges of the graph, and then eventually out the top, what we call a root operator, to the end node, to the end user. Now, like all database engines, our optimizer is tasked with producing efficient query plans to execute the queries that we're asked to perform. However, our query plan in Ocient's system incorporates network connectivity information embedded into the plan itself that the optimizer is able to use to make intelligent decisions about exactly what computation to run where. However, in accordance with our global information minimization, the exact number of nodes and the exact series of nodes that will be participating in querying is not known to the optimizer up front. It is not required that the optimizer understand exactly that a given node is online and available and will answer a query, or that another node is going to take over for it. Instead, the optimizer works simply in terms of query levels, delineated by special operators in our plan that we call gathers, that essentially act as either a fan in or a fan out, depending on your point of view. When performing the optimization passes, the optimizer understands that moving information over gather boundaries incurs not only the cost of the processing, but the network cost as well. And this gets incorporated into our modeling, such that the optimizer makes intelligent decisions about how the query will execute at scale across the network boundaries without having exact information on which nodes will perform the execution. This has been an overview of Ocient's approach to a couple of topics related to scale. If you'd like more information or have any questions, please visit our website.